e to the x, okay? E to the x is actually its own derivative. What do I mean? What's the derivative of e to the u? Well, it's e to the u. But don't forget, we still need to multiply it by the derivative of u. Okay? So if you want to write this another way, if you want to write it like this, e to the u times u prime, because a lot of you guys, I think, like seeing it that way better. Don't forget, you still got to multiply e to whatever it is times the derivative of whatever it was. Okay? Okay? So for example, what is the derivative of e to the sine x? It is the same thing. Okay, I want to find this. Here you go. That's e to the sine x times the derivative of sine x, which is cos x. Okay? So, what is the derivative of e to the 5x? Times 5. And we would write that as e to the 5x times 5, and we write it up with the number first, 5e to the 5x. All right? Simple. A to the x, where the variable is in the exponent. Okay, that is an exponential expression, and the variable is in the exponent. That's what we call exponential. That is, you ready for this? Yeah. This one doesn't happen a lot. Okay? This one doesn't, occasionally it does. This one happens a whole lot. Okay, you know this one. Okay? This one sometimes. Okay. A to the u times the ln of a times, so it's a to the u times the ln of a, but don't forget times the derivative of whatever u is. If you want to write that to u dx as u prime, go right ahead. In other words, it's a to the u times the ln of a times u prime. Alright? So let me give you one. Huh? I know. Okay, so find the derivative of 5 to the 3x. What would that be? Yeah, I start out writing the same thing, 5 to the 3x times the ln of whatever a is. The ln of whatever a is, right. Times the ln of 5 times the derivative of u. This is u, so it's the derivative of 3x. I mean, you can't multiply the 3 times the 5 because the 3x is connected. And I can't multiply the 3 times the 5 with the ln because the function has to happen just for the 5 solely. So yeah, you kind of got to write it like that. These are parentheses. Maybe put the 3 out in front because that typically comes before like logs like that, just coefficients. So if it was multiple choice, it might be written like this: times 5 to the 3x times ln. Okay. Well, they might be a little bit more complex than that with like trig in there or whatever. Maybe you got to do a chain rules, whatever's in here, you know. So you'll see it. All right. This is the other common one besides e to the u or e to the x. This is the other one. This is simply 1 over u times the derivative of u. Okay? This one's very common, especially when we start learning antiderivatives, meaning we have the derivative and we've got to find the original equation. We're backward. They might say 1 over x. What did I have to get 1 over x's derivative? Well, we had ln of x to get it. So that's working backwards. All right? So, how about we do this? How about we do this? Here's an example. Find the derivative of the ln of 3x plus 5 squared. Okay? So how do I write that? Well, yeah, it's 1 over. What's my u? This right here is my u right now. So the derivative is 1 over that. 1 over 3x plus 5 squared times, well, the derivative of u. That's the chain rule. The 2 comes out front. I drop the exponent by 1, right? And then times the derivative of the inside. Like, think of it. I got to find the derivative of just this. Okay? What's the derivative of just that? Well, this has got to come up front. That shrinks by 1 times the derivative of the inside. Right? That's what I'm talking about, how sometimes you can get a little bit more of the chain rule inside of you. So what will this end up being? This will be 6 times 3x plus 5. If you wanted to distribute that, you can. That's this right here, u prime. That's what this is. So times 6, 3x plus 5. Okay? And if I'm multiplying them together, I should write them as one fraction. I should write 6 times 3x plus 5 all over 3x plus 5 squared. You see what I'm saying? I just combined them. Right? But this is common right here. The ln of 3x. The ln of x is 1 over x. It's a big one, you should know. The derivative of e to the x is just e to the x. No, those are the 2 big ones. Not that common. Not that common. Is this the last one? I mean, the worksheet will have these on there. When it comes to testing and things like that, the ln of x and e to the x are the 2 big ones. Right? So log base a of u is, oh my lord, 1 over u times the ln of a times the derivative of u. All of these always get multiplied to the derivative of u. Okay? So, that's a tough one. Okay? Find the derivative. No, this is not one of the common. E to the x is the first one, and ln of x is the third one. Okay, those are the common ones. Those are the common ones. On my decimal on the left side is the basic decimal. All right, so let's find the log base. No, this is what I'm going to do. Log of 5x squared. What's the derivative of that? What's the derivative of that? The derivative is 10. Wait. Someone just asked me, why aren't you putting a base there? So there's a base there. Yeah, whenever there's no number written, it's 10, isn't it? Just like, if I do this, I assume it's a square root. I don't have to put a 2 there. If I want a cube root, I have to put a 3. If I do this, I don't put a 1 here for the exponent because I assume it's a 1. I don't put a 1 there for the coefficient. I assume it's a 1. If there's no number in here for log, it's a 10. So, how do I write that? How do I write that? Thanks for the test, because teachers need to be tested too. So it is 1 over 5x squared, because that's my u, times the ln of 10, because that's my a, times the derivative of u, which is 10x. And if I want to clean that up, I just put 10x over 5x squared. Ooh, wait a second. What can I do? You take this like that. I can reduce. And then I can reduce. Oh, it doesn't work. Great. I heard it. What can I do? I can reduce. What does that reduce to? What does that reduce to? 2 over. Yes, thank you. 5 goes into here twice. It got twice. Way to work, Tommy. And x goes into this x 1 time with the remainder of, there's 1 left. So it's actually 2 over x ln of 10. We're trying to leave you guys followingly to say more things, so you guys just weren't following. That's every day. I would say like once a week, maybe more, maybe less. There's teachers always have dates like that. 2 plus 2 is... The whole class was staring at you. 2 plus 2 is 4. Never in calculus, though. In pre-calc sometimes, but not in calculus. All right, so there you go. I have a worksheet for you. You guys can practice it in the whole...